Okay, so we had snow day number 7 today. So if you look on the schedule, we were scheduled today, it was going to be homeroom, snow day number 7, and that puts 7-3 tomorrow. But tomorrow is 3AB assembly schedule, and I'm not sure how much time we'll have for the lesson. So I'm going to record the whole thing today, and then because it's later than expected, most of you probably won't see this anyway, but if we don't finish tomorrow, you can go back and reference it and go through the lesson. So here we go. I'm going to start with a review of yesterday. We were in 7.2 and we're finding polynomial models. So we had a list of the polyhedral numbers and we did rows of subtracting. Our goal was until we got a constant or same difference. Since it took us 3 rows of subtracting, then it was a third degree polynomial. Once we knew that it was a third degree polynomial, then we took the generic form of a third degree polynomial. We made a system of equations because there are 1, 2, 3, 4 terms. We needed 4 equations. So we got these by picking 4 points, plugging in the x value for x, the y value for y, writing the equations here. And then from the system of equations, we used matrices. So we put the coefficients into a matrix A. We put the y values, which were over here, into a matrix B. And then we reviewed that the solution to that system is to type matrix A inverse times matrix B. And our solution matrix gives us the coefficients or the values for the variables A, B, C, and D, which are the coefficients of the terms. And we came up with the equation for tetrahedral numbers. So that's where we were in 7.2. It was a repeat of something we had done earlier this year. Third period, I don't think that you got time to write this in the blanks. So this is the function with equations y equals f of x is a polynomial function of degree n. IFF means if and only if, oh, pardon me for yawning, for any set of x values that are consecutive terms of an arithmetic sequence, the n differences of corresponding y values are equal and non-zero. So a quick review of what that actually means in English is you had x values. These x values had to form an arithmetic sequence. They could be consecutive numbers, meaning they go up by 1 each time. They could go up by 2 or 3 or 4, but no matter what, they have to go up by the same amount each time. Then we did repeated subtractions of the y values and until we got a constant difference. That constant difference gave us the degree of our polynomial. We put them in the equation. Oh, I'm yawning. Used matrices and solved. So this is a proof. I'm going to just let you read through it. So I'll leave it up here. You, of course, can read it, stop it, go back. So I'll just kind of flip through so you have access to these pages. Now here's another example for you to follow. So let me start over. Maybe. Okay, so you have a list here of your x's. Notice they go up by 1 each, so they're consecutive terms. And then here are the y values. We do repeated subtractions. 125 minus 68 is 57. 68 minus 33 is 35. 33 minus 14 is 19. 14 minus 5 is 9. 5 minus 0. These are not the same numbers, so we subtract again and get each of these differences. Still, they're not the same numbers, so we subtract one more time. Now we get 6 each time, so we have a constant difference. So now with that constant difference, we pick, because it's a third degree again, there are 4 terms, so we need 4 equations. So here we picked, looks like we picked 1, not 0, picked 1, 2, 3, and 4. Each time we plugged 1 in for x. 1 cubed was 1, 1 in for x, 1 squared is 1, and so on. It equals, when x is 1, y is 5, so it equals 5. We plug in 2. 2 cubed is 8, 2 squared is 4, 2, 1, and 14 is the y value. 3 cubed is 27, 3 squared is 9, 3. And then 1D, and then we plugged in 4. So here is our system. After we have our system, then we need to plug in and get the matrix values. So our coefficient matrix is 1, 1, 1, 1. So 8, 4, 2, 1, 27, 3, 9, 3, and 1. 64, 16, 4, and 1. Then we store that in matrix A, and these are the coefficients. Then we take the constants or the answers over here and list those. So 5, 14, 33, and 68. We store those in B. Our solution is gained by doing A inverse times B. Once we type those in, we get a solution matrix. The first answer is A, the second one is B, the third one is C, and the fourth one is D. And we have our solution. Now let's go on and start 7.3. Find a quotient and remainder when one polynomial is divided by another polynomial of lesser degree. Polynomial long division. I'm so bummed if I don't get to teach this in class. Do you remember division from elementary school? Long division? Probably a lot of you are saying no. So when I do this in class, I act like I'm 3 years old and you have to teach me how to divide. Sadly, I'll just have to do it here. So 6780 divided by 23. So I say to myself, self, what do I multiply 23 by, or how many times does 23 go into 67? The answer is, does it go in 3 times? Not quite. So we're going to go 2. 2 times 23 is 46. Then we subtract. 7 minus 6 is 1. 6 minus 4 is 2. We are close to having 3, but not quite. Bring down the next number, which is 8. 23 times what goes into 218? Well, I know 10 times 23 would be 230, and that doesn't fit. Let's try 9. 9 times 3 is 27. Carry the 2. 9 times 2 is 18 plus 2. Sorry about the cough. 207 8 minus 7 is 1. 1 minus 0 is 1. 2 minus 2 is 0. Bring down the next digit, which is a 0. And then how many times does 23 go into 110? 5 times 20 is 100. 5 times 23 I think would be 115. Let's try 4. 4 times 3 is 12. Carry the 1. 4 times 2 is 8. Plus the 1 is 9. Borrow. 10 minus 2 is 8. 10 minus 9 is 1. So 18 is our remainder. So when you were in the small grades, you might have written 294 remainder 18, or you may have written 294 and 18 over 23. That's old school division. We're going to be doing the same thing today with polynomials. So let's look at this. What is the mathematical relationship? The quotient is the answer. So the quotient in this case was 294 and 18 over 23. The dividend is what we divided into, 6780. And the divisor is what we divide by, 23. Our remainder then was 18. Again, if you're going to say the 18, you don't write 18 over 23 or here also. Okay, moving on. Let's try this. Another way to divide is by factoring. So you factor x squared plus 8x plus 15. You get x plus 3 times x plus 5. Ready for canceling? Cancel those out. And our answer is x plus 3. This is much simpler if you have something that's easy to factor. Let's try a few more. This is the whole algorithm, all the steps that we go through. Again, you can always pause the recording and look. The key to this is asking yourself the right questions. So here we go. Self. What do I multiply x by to get x squared? And I go first term to first term once this is in standard form. So the answer is x, because x times x is x squared. So I multiply it. X times x is x squared. I write it underneath its like term. X times 5 is 5x. I write that underneath its like term. Subtract. X squared minus x squared is nothing. 8x minus 5x is 3x. Bring down the next term instead of the next digit, plus 15. So I say to myself, self, what do I multiply x by to get 3x? And the answer is 3. I separate each of these by a term. So 3 times x is 3x. 3 times 5 is 15. 3x minus 3x is nothing. 15 minus 15 is 0. I've now divided. So each time I take the first term of my divisor, I look at the first, most recent first term, leftmost term, this thing, and I say, what do I have to multiply this by to get that? You can go by, if this doesn't make sense, you can go back and replay. We are going to do some more dividing. So this time we have to set it up. Whoa, I don't know where that came from. Here we go. So we go 6x squared plus 13x minus 5 divided by 3x minus 1. So I say to myself, well actually I'm going to slide the whole thing down a little bit so we have a little more room. There we go. Okay, what do I multiply 3x by to get 6x squared? And the answer is 2x. 2x times 3x is 6x squared. Also distribute to the second term, 2x times minus 1 minus 2x. Each time I write it underneath its like term. Put parentheses and subtract. 6x squared minus 6x squared is 0. We design it this way. That's why we multiply the 2x times the 3x. If you don't get 0, go back and check. Something's wrong. 13x minus a minus 2x. Minus a minus is same as adding. So 13x plus 2x is 15x. bring down my next term, minus 5. What do I have to multiply 3x by to get 15x? The answer is 5. 5 times 3x is 15x. 5 times minus 5 is minus 5. Subtract. Make sure you put parentheses around these and subtract each time. Most common error is to mess up your signs on this second part of the binomial. So 15x minus 15x is 0. Minus 5x minus a minus 5x is adding. As minus 5 plus 5x, it's 0. So 6x squared plus 13x minus 5 divided by 3x minus 1 is 2x plus 5. Stop the recording. Try this on your own. Actually, watch for a minute. Let me help you get it set up. Then stop it. Try it on your own, and then come back and check. Because we have a unique situation here. We have 5x cubed. We don't have an x squared term. So we're going to use a placeholder. 0x squared minus 2x minus 36. And then we're going to divide by x minus 2. Stop the recording. Try this on your own. Then come back and check your work with mine. Welcome back. Here we go. So here's how I'm working it out. Self, what do I have to multiply x by to get 5x cubed? And the answer is 5x squared. 5x squared times x is 5x cubed. 5x squared times minus 2 is minus 10x squared. Write it underneath its like term. Parentheses, subtract. I get 0 here. And then 0 minus a minus 10x squared is positive 10x squared. What do I multiply x by to get 10x squared? The answer is 10x. 10x times x is 10x squared. Oh, I didn't bring down my other term. There it is. And then 10x times minus 2 is minus 20x. Parentheses, subtract. So, 10x squared minus 10x squared is 0, as it should be. Minus 2x minus a minus 20x is a positive 18x minus 36. What do I have to multiply x by to get 18x? The answer is 18. 18 times x is 18x. 18 times minus 2, minus 36, parentheses, subtract, remainder of 0, win in evenly. You can play this back as many times as you need to get the process. It's really a process of asking yourself the right questions. Okay, so with remainders, I'm just going to go ahead and go to this next problem. Again, this skips terms. Remember to put in 0 for a placeholder. Notice here that these also skip terms. We don't have to write the placeholder. If you want to, you can. I'll get it started for you, and then I recommend that you finish, come back and check. So when I write it out, I write 2x to the 4th minus 8x to the 3rd plus 0x squared as my placeholder plus 12. Now I'm dividing by x squared minus 2. So what do I have to multiply x squared by to get 2x to the 4th? 2x squared. 2x squared times x squared is 2x to the 4th. 2x squared times minus 2 is minus 4x squared. Write it underneath its like term. Still parentheses, still subtract. 2x to the 4th minus 2x to the 4th is nothing, 0. Minus 8x to the 3rd minus nothing is minus 8x to the 3rd. 0x squared minus a minus 4x squared is plus 4x squared. Bring down another term. What do I have to multiply x squared by to get minus 8x cubed? Minus 8x. Minus 8x times x squared is minus 8x cubed. Minus 8x times minus 2 is plus 16x. Oh my goodness, I didn't write a placeholder. What am I going to do? Pretty easy. I can just put one in. So I put plus 0x. And now when I go negative x, 8x times minus 2 is plus 16x. See, as long as you keep your pattern down, you can go back and figure out what you need to put in. So 8x cubed minus a minus 8x cubed is nothing, negative 8, sorry. And then 4x squared minus nothing is 4x squared. 0 minus 16x is minus 16x plus 12. What do I have to multiply x squared by to get 4x squared? The answer is plus 4. 4 times x squared is 4x squared. 4 times minus 2 is minus 8. Do I put it here? Nope, put it under its like term. Subtract. 4x squared minus 4x squared is 0. Minus 16x minus nothing is minus 16x. And 12 minus a minus 8 is adding 8. So plus 20. So this is my remainder. I could either write it as remainder minus 16x plus 20. More commonly, we write it as a fraction. 2x squared minus 8x plus 4. Write a plus sign. Put the minus 16x plus 20 on the top. And put it over what we divided by. So x squared minus 2. So there is our final answer with our remainder written as a fraction. If you need to, turn this off, go back and look at it. We're going to keep practicing. I'll do the practice, you do the practice, I'll do the practice, so turn off the recording, come back, and check your work. Okay, here's how I did it. So 12x squared plus 8x plus 1 divided by 6x plus 1. I need 6x times 2x equals 12x squared. 2x times 6x. 12x squared, 2x times 1 plus 2x. 12x squared minus 12x squared is nothing. 8x minus 2x is 6x plus 1. What do I multiply 6x by to get 6x plus 1? 1 times 6x plus 1. Subtract. Goes in evenly, no remainder. Here I'm skipping a term. X cubed plus 0x squared minus 7x plus 6. Divide by x minus 2. What do I multiply x by to get x cubed? That's x squared. Make sure you can see that 2 there. X squared times x is x cubed. X squared times minus 2 is minus 2x squared. Parentheses. X cubed minus x cubed is nothing. 0 minus a minus 2x squared is 2x squared. Bring down minus 7x. What do I have to multiply x by to get 2x squared? The answer is 2x plus 2x times x is 2x squared plus 2x times minus 2 is minus 4x. Parentheses, subtract. 2x squared minus 2x squared is nothing, 0. Minus 7x minus minus 4x is adding 4, so minus 3x plus 6. What do you have to multiply x by to get negative 3x? The answer is minus 3. Minus 3 times x, minus 3x, minus 3 times minus 2, plus 6, and 0. And here's another one. 2x squared minus 5x plus 4. X plus 1. Multiply by 2x. 2x times x is 2x squared. 2x times 1 plus 2x. Minus 5x minus 2x is minus 7x plus 4. multiply by -7, minus 7 times x is minus 7x, minus 7 times 1 is minus 7. Subtract and you get 0. 4 minus a minus 7 is adding 7, so you get 11. So we write plus 11 over x plus 1. Here you have x cubed plus 0x squared plus 0x plus 27 divided by x minus 3. Multiply x by x squared. X squared times x is x cubed. X squared times minus 3x squared. Parentheses subtract. X cubed minus x cubed is 0. 0 minus a minus 3x squared. Positive 3x squared. Bring down the next term, which is 0x. Plus 3x times x. 3x squared plus 3x times minus 3, minus 9x. Subtract and get 0. 0 minus a minus 9x is a positive 9x. Plus 27. Multiply by plus 9, you get 9x plus, minus 27. Almost fell for that. So we do have a remainder of 54. So this is long division. Hopefully each time you stopped, you tried it on your own, you came back and looked at mine as you need help. I will leave these up here. This is student work from last year if you need help with the process, but there's the work. And there is a shortcut, so if you were thinking, I would love to have a shortcut, sometimes you can have a shortcut. And let me show you how this goes. So the first thing I did was I took the coefficients of each of these terms. So 1 minus 4 minus 25, 78. 1 minus 4 minus 25, 78. Then I take this, and these are written for equations of the form x minus c. So if you compare these, you see that c is 6. When it's x minus 6, c is 6. And that's what goes right here. C goes right here. Now it's simply an algorithm, meaning just go through the steps. We bring down the 1. Sorry, I had trouble lining them up when I made this in PowerPoint. So we bring down the 1, and then we go 6 times 1 and write it there. Then 6 times 2 and write it there. Then 6 times minus 13 and write it there. So it was simply 6 times this. Okay, now let's go back through that process. So bring down the 1. 6 times 1 is 6. So then minus 4 plus 6 is 2. 6 times 2 is 12. Minus 25 plus 12 is minus 13. 6 times minus 13 is minus 78. 78 plus a minus 78 is 0. This is your remainder. Then these are the terms of your answer, starting with, this is the constant at the far right. So this will be the coefficient of the x term, the coefficient of the x squared term. So our answer then is x cubed minus 4x squared minus 25x plus 28 divided by x minus 6 is 1x squared plus 2x minus 13, remainder is 0. Let me see if I can shrink this a little bit so you can see all the algorithm steps. Whoa, whoa, get back here. Oh, as you can see, it's not cooperating at the moment, but we're going to end up with a screen's worth that you can see. And I'm going to move on. Freeze this if you need to read it. Okay. we need to take the coefficients here. Notice we're missing an x squared term. So the coefficients are 3, 0, -17, and 30. Remember, we're comparing to binomial of the form x minus c. So in this case, c is not 3, but -3. Here we go. Bring down your 3. -3 times 3 is -9. Add them, -9. -3 times -9 is positive 27. Add them, 10. -3 times 10 is -30. Add them, 0. So our remainder is 0. I always put a box around it so I don't put it in my answer. And which means my answer, here's my constant term, my x term, my squared term. So 3x squared minus 9x plus 10. And that's my answer. Try the next one and then come back and check with me. I'm going to go for it. So I have 1, I have no x cubed term, I have -10 for my x squared term, I have -2 and 4. In the box, compare this to x minus c. So in the box I write -3. Okay, here we go. Bring down the 1. -3 times 1, -3. Add. -3, -3 times -3, 9. Add. -1, -3 times -1, 3. Add. 1. -3 times 1, -3. Now I have a remainder of 1. My constant term, my x term, my x squared term, my x cubed term. So the answer is 1x cubed minus 3x squared minus x plus 1 over x plus 3. Synthetic division, however, only works if the thing you're dividing by is of the form x minus c. So no number in front of x. Biggest power can be 1 and no coefficient of x. So x plus or minus any number here. That's the only time we can use synthetic division. Now I hope some of you, as we did this, didn't just blindly follow it, but thought, why does that work the way it works? So if you want to take some time, go through and figure out why synthetic division works the way it works with this algorithm, do that, write it up, and I'll give you some extension points for doing so. So let's go back here, and here's some student work from class. So do your work and then compare it to these results. I'll explain what I just erased later. And see if your answers agree with these. Again, I can erase if my cursor will work. Well, my cursor may not work. But I can erase this for now, and then I'll explain it later. And here's the remainder. Hopefully this is page 12 in your notes. And let's see what we have here. The remainder theorem. If a polynomial f of x is divided by x minus c, notice that's the same form that we could use in synthetic division, then the remainder is f of c. Plug c into the polynomial and get your answer. That's what was going on here. So plug, in this case c was 2. Plug 2 into the equation. So f of 2 equals, rewrite the numerator. So 2 cubed, plug that in for x, minus 7 times 2 plus 9. 2 cubed is 8, minus 14 plus 9, minus 6 plus 9 is 3. What was the remainder? Well, look, it was 3. That's a demonstration of the remainder theorem. Now there it is if you need to write it down. Pause here. And this is what we just did, was finding the remainders of those. And that finishes 7.3. Let me go back and find the title page. Make sure we met our learning targets. Where did it go? There it is. I can find the quotient and remainder when one polynomial is divided by another polynomial of lesser degree. And let me write that out. So you have your quotient. It is the answer. What you divide by is the divisor. What you divide into is the dividend. And then of course you get a remainder. Or your remainder is 0. Alright, I hope this makes sense. Go back and play any parts you missed. And see you soon.